All right, welcome to Unit 1, Function Analysis. In this video, we're going to talk about asymptotes. Asymptotes are a very important property that a lot of functions do have. Not all functions, but some functions do have. So in this video, we're going to talk about two different types of asymptotes, vertical asymptotes and horizontal. So keep in mind that a vertical asymptote is an asymptote that goes up and down. And when a function approaches a vertical asymptote, it's either going to shoot straight up towards infinity, or maybe it shoots straight down towards infinity. Or it could do both. One side can go up and the other side can go down, what have you, but those are vertical asymptotes. Horizontal asymptotes are horizontal lines that look like this. And as a function approaches a horizontal asymptote towards the far end, it'll just keep running and running and running and never, ever, ever, ever cross that horizontal asymptote. Same thing going towards negative infinity. It'll keep running and running and running and never actually cross that horizontal asymptote. So you got to understand vertical asymptotes are x values. These are x values that we cannot be. For example, if there is a vertical asymptote at x equals 3, that means there's going to be a vertical line at x equals 3, and x could never ever equal 3. X is not allowed to equal 3, which is why there's an asymptote there. Horizontal asymptotes are y values, right? They're values in the range, not the domain, the range, the y values that you cannot be. So for example, if there is a horizontal asymptote at y equals 2, what that means is to the far right where x is going towards infinity, or the far left where x is going towards negative infinity, the function will slowly approach 2. It'll never get to 2. It'll be like 1.9999999 or maybe 2.0000001, but it'll never ever get to 2, for example. All right, so let's talk about vertical asymptotes for a little bit here. So vertical asymptotes occur when there is an x value that makes only the denominator of a rational function equal to 0. So the only ever time you're even going to ever have to worry about a vertical asymptote is if there is an x or a variable in a denominator. So if you have a variable in a denominator, you do have to be on the watch out for vertical asymptotes, and they are any value that only make the denominator 0. Now I say only because there are some values that will make the denominator and the numerator 0. If there is a value that makes the denominator and the numerator 0, that actually creates a hole in the function, which is like a gap or a hole in the function. So that's different. It's not a vertical asymptote. So it's really important that you understand that vertical asymptotes occur when the denominator only turns into 0. So here's an example of a vertical asymptote. Notice that I made it pretty easy to see that the number 5, x equals 5, makes this denominator 0. So x cannot equal 5. And if I plug 5 in, on top I get 7. 5 plus 2 is 7. But on the bottom I get 0. And that just cannot be. So that creates what we see in the graph here as a vertical asymptote. Now, officially, you don't see it in the graph. We like to put this dotted line in there to show it, that it cannot equal 5. So the big question a lot of students ask is why? Why does this graph happen? Well, just think about this for a second. As x starts to approach that vertical asymptote, so we know when x is 1, we plug in 1, we get a 3 on top. So f of 1, we get a 3 on top. 1 minus 5 on the bottom is a negative 4. So at 1, we're at negative 3/4. Somewhere right around there. It looks all pretty, right? But let's talk about really, really close to 5. As we get close to 5, like 4.99. So let's just jump on our calculator. If I plug in 4.99, I get 4.99 plus 2. So my numerator is just short of 7. And the denominator is 4.99 minus 5. A very, very, very small negative number, negative 0.01. Now, if you remember anything about maybe back in 6th grade, 7th grade, is when you divide by a teeny, tiny number, you actually get bigger. So if I take 6.99 and I divide by negative 0.01, I divide by a very small number, notice I get really big, negative 699. So that is why when we approach 5 from the left-hand side, and we're really close to 5, like 4.99, we're shooting straight down, way down to negative 699. Really, really, really low. That is why you see this graph here, it's going straight down. It's just going straight down at that point. And the same thing is said to be true coming from the right-hand side. So if we were to pick a number that is really, really close to 5, but from the right. So for example, 5.002. And on the numerator, I'm going to get a number really, really close to 7, just a little bit above 7. And the denominator, I'm going to get 5.002 minus 5. I'm going to get a very, very small positive number. And when I divide them, keep in mind what happens when you divide by a really small number, you actually get really, really big. And that's why it shoots me, look at that, 3,501. So at a value that is really, really close to 5 on the right-hand side, no wonder the graph is way, way, way up here at negative 3,500 some. So that's what's happening as we approach a vertical asymptote. We're either going to shoot straight down if we're negative or straight up if we're positive. All right, so let's talk about horizontal asymptotes. Horizontal asymptotes occur when the function cannot equal a particular value that's not in the range. Remember, horizontal asymptotes deal with the y value. They're y values that we just cannot be. So let's look at some of the simplest examples here. Now, this first one is going to have a horizontal asymptote at y equals 0. That's actually the x-axis. Now let's talk about y though. Remember that where does a function equal 0? Well, a function equals 0 when the numerator is equal to 0. Well, this numerator is 1, which means that this function will never, ever, ever be 0. It doesn't matter what you plug in for x, you're never going to get a 0 in the numerator. And if the numerator is never allowed to be 0, well then that's a horizontal asymptote because you're never going to get an output of 0. It's just never going to happen. So if you take a look at the graph of this guy, it's going to look like this, where on the far left, the graph is slowly going towards 0, and on the far right, the graph is slowly going towards 0, and you cannot equal 0 because there's a 1 on the top, and it's a 1. It's never, ever going to be 0. All right, this example over here has a horizontal asymptote of y equals 1. Now let's talk about why that is. Remember, the number 1 in terms of a fraction is when your numerator and denominator are the same number. 5 over 5 is 1. 7 over 7 is 1. 6 over 6 is 1. Negative 7 over negative 7 is 1. But check this out. This numerator is x plus 2. It's x plus 2. And the bottom is x minus 5. So though the numerator and the denominator, they're never going to match up. They're never. Because if I plug in 3, for example, I get 5 on top, and I get a negative 2 on the bottom. If I plug in 6, I get 8 on top, and I get a 1 on the bottom. The numerator and the denominator are never, ever, ever going to match up, which means you are never, ever, ever going to get a y value of 1, which is why there's a horizontal asymptote at 1. Okay, that should make some kind of sense. Now, both of these graphs, just as a side note, also have vertical asymptotes. This first function here on the left, because x makes the denominator 0, that means there's going to be a vertical asymptote here at 0 as well. And this graph over here is going to have a vertical asymptote at y equals, not y, excuse me, x equals 5, is that's the same problem we looked at earlier as well. Now, this idea of horizontal asymptote actually talks about something that we call end behavior. End behavior is what is the function doing, or what is the graph doing? Remember, the graph is just a picture of the function towards the ends. Now, when I say the ends, I mean the far left or the far right. And that's what we're talking about here. So from that first example, 1 over x, we talked about there being a horizontal asymptote at 0. Because the numerator is 1, it'll never, ever be 0. It can't. It's impossible. So we talk about that graph. We talk about the right end behavior. As we go far to the right, 10, 20, 30, 1,000, 2,000, I'm talking way towards infinity, the graph is going to get closer and closer and closer to 0, but it will never, ever, ever get to 0. Okay? Now, if you want to think about why that makes sense, get out your calculator. So if I take 1, I divide it by 10. Okay, 0.1. Not 0, but close to 0. And if I allow my x value to go far to the right, meaning bigger towards infinity, let's divide it by 526, for example. Certainly not infinity, but that's 526 is pretty far to the right. Notice I get a number very, very small. Not 0, but very, very close to 0. And the further I go to the right, 1,478, the closer I am to 0, but I'm never going to get there. So notice that's a scientific notation. That'd be 0.000676589. Again, a very, very small number. And the same is true when I go to the left. When I go to the far left, the only difference is I'm negative, but again, I'm still close to 0, but I'm not 0. For example, if I go far to the left, 1 divided by negative 3,652, I am very, very small. Again, that's scientific notations. That's negative 0.00027. It's a very, very small number to the far left. So this is what we call end behavior. We're talking about what's the graph doing at the far left and the far right ends. And when there's a horizontal asymptote, you are approaching a particular number, but you're never going to get there. So as x goes way towards the right, the function is getting closer to 0, but it's never going to get there. And as x goes way to the left, the function is never going to get there, but it's getting really, really, really close to 0. All right, now the question is, how do you find horizontal asymptotes? This is something that you should have definitely learned in Algebra 2, but we will quickly review it. To identify horizontal asymptotes, first and foremost, they only occur when you have a rational function where you have an x in the denominator. So when you do see an x in the denominator, all you have to do to determine your horizontal asymptotes is look at the degree of the numerator and the degree of the denominator. Now, if you don't know what degree means, take a moment and Google it, but the degree is the largest power in the numerator or the largest power in the denominator. So if the degree of the denominator is bigger than the degree of the numerator, there is automatically a horizontal asymptote at y equals 0. So if the denominator's degree is bigger than the numerator, you automatically have a horizontal asymptote at y equals 0. And if the degree of the denominator is smaller than the degree of the numerator, there is no horizontal asymptote, so you don't have to worry about it. And if the degrees are equal, meaning the numerator and the denominator are tied, the same degrees, what you then do is you look at the leading coefficients to determine your asymptote. You take the leading coefficient of the numerator and you divide it by the leading coefficient of the denominator. Now, hopefully that sounds familiar, but let's do a couple practice examples. So what's the degree of the numerator? It's the 1 right here. What's the degree of the denominator? It's the 2 right here. So here's an example where the denominator's degree is bigger. So there's automatically a horizontal asymptote at y equals 0, automatically. Here's an example where the degrees are tied. The degree on top is 2, largest exponent. The degree on the bottom is 2. So now we look at leading coefficients. So the horizontal asymptote is taking the leading coefficient of the top, which is 3, and dividing it by the leading coefficient of the bottom, which is the 1 that we can't really see right here, but it's there. And therefore, we have a horizontal asymptote at 3. In this bottom example, the degree of the numerator is 3. The degree of the denominator is 2. Since the denominator is a smaller degree, there are no horizontal asymptotes. It's really, really, really that simple. All right, let's take a look at 3 more examples. And for each of these examples, we're simply going to find all asymptotes. All right, now one thing that does help is factoring, making sure that everything is factored. That sometimes helps. But let's look at this first example here. All right, well, I know that negative 1/2 makes the denominator 0. Therefore, I'm not allowed to equal negative 1/2. So there is a vertical asymptote at x equals negative 1/2. Now, if you're like, how did you get negative 1/2? All you got to do is take the denominator, set it equal to 0, even though you're not allowed to equal 0, but solve anyway. Subtract the 1, divide by 2, you get negative 1/2. Now I have to look at the degrees to find the horizontal asymptote. The degree of the numerator is 1. The degree of the denominator is 1. They're tied. So there is a horizontal asymptote at, look at the leading coefficients, 1 divided by 2. So there is a horizontal asymptote at positive 1/2. Pretty simple. All right. Now for this middle one here, we got to make sure we're careful to factor the denominator. X minus 3 times x plus 3. Because this is super important for something I mentioned in the very beginning of this video. There is a vertical asymptote, but there's only a vertical asymptote at x equals negative 3. That's because if I plug negative 3 into this factor right here, I get 0. Can't have a 0 in the denominator. But notice 3. Some students are going to say, well, wait a minute. 3 makes the denominator 0 as well. 3 squared is 9. 9 minus 9 is 0. But remember, looking at this, 3 also makes the numerator equal to 0. And when a value makes both the denominator and the numerator equal to 0, it's not a vertical asymptote. That's where holes get created, a different topic. So there's only one vertical asymptote at x equals 3. Now, what about horizontal asymptotes? The degree of the bottom is 2. The degree of the top is 1. And if the degree of the bottom is bigger, then we automatically have a horizontal asymptote at y equals 0. So there's automatically a horizontal asymptote at y equals 0 anytime the bottom degree is bigger. All right, one more to go here. Once again, it's going to help the factor if possible. So let's take a moment to see if the numerator is factorable. So let's see here. Man, this is a good time to work on your factoring skills. So 6x squared, I'm thinking 3x times 2x and 1 times 2. Now I just got to figure out where they need to go. Let's put the 2 here and the 1 here. Let's see if this works. That's going to be a 6x on the outside, a 2x on the inside. A 6x and a 2x is not going to get a negative 1 in the middle. So I don't want to do that. So let's erase and go back to the drawing board here. All right, let's try, let's see here. Let's try the 2 right here and the 1 right here. So that's going to give a 3x on the outside and a 4x on the inside. Ooh, I like this, because if I make the 4 a negative and the 3 a positive, this is going to work. So on the outside, I have a 3x. On the inside, I have a negative 4x. That generates the negative x in the middle. And then negative 2 times positive 1 makes the negative 2 in the end. And then my denominator is, honestly, it's unfactorable. 3x squared plus 1 cannot be factored. So let's talk about vertical asymptotes. Are there any numbers that make the denominator 0? Now, there's a couple answers, or a couple different ways you can realize that the answer is no. The denominator will never, ever be 0. First off, just think about it. You're adding 1, meaning that if you plug any number in and you square it, you're going to get a positive. All numbers squared are positive. Times it by 3, it's only going to get more positive, and then add 1, we're even more positive. So the bottom can never, ever be 0. Now, if you're still like, I don't quite understand that, just take a moment. Let's set it equal to 0 and literally ask yourself, are there any numbers that let the denominator equal 0? And then when we start solving, this happens. We get negative 1/3, and then we say, oh, let's take a square root. And then you're like, wait a minute, you can't take the square root of a negative number, which is why there is no way that the denominator will ever be 0. So there are no vertical asymptotes to worry about. All right, horizontal asymptote, top degree is 2, bottom degree is 2, they're tied. So to find the horizontal asymptotes, all you got to do is divide the leading coefficients. So that's going to be the 6 divided by 3, or 6/3, which is 2. So we have a horizontal asymptote at y equals 2, but no vertical asymptote because no value makes the denominator equal to 0. So kind of a mixture of some good problems that allow you to see the different things that can happen when we're talking about vertical and horizontal asymptotes. But this video really just kind of covered the basis of it. You know, the first thing you need to understand is that these issues occur with rational functions. They do occur in some other weird functions, like log functions have vertical asymptotes, and exponential functions have horizontal asymptotes. But, you know, we only see really the combination of them both is when we're working with rational functions. All right, guys, that's it for this video on asymptotes. Be ready to answer some questions over it.